Hello everyone, my name is Santosh and I am a student of Chemistry Honors first year. It is an audio video lecture on gaseous states. Among the three states of matter, the gaseous state is the simplest one. Gases show maximum uniformity in their behavior irrespective of their nature. Gaseous state is characterized by the following physical properties. Gases possess capacity of indefinite expansion. They acquire the volume and shape of the container. Gases are highly compressible. Unlike liquids and solids, gases can be liquefied at low temperatures and high pressures. Gases have very low densities under normal conditions of temperature and pressure. Gases intermix spontaneously, and this property is known as diffusion. Gases exert pressure on the walls of the container. Gases exert pressure equally in all the directions. The important measurable properties of gases are mass, volume, pressure, temperature, etc. The behavior of gases can be understood in terms of some relationship between these variables that are pressure, volume, temperature, and mass. These relationships are known as the gaseous laws. Gases which obey the gas laws at all temperatures and pressures are called ideal gases, while gases which do not obey these laws at all temperatures and pressures are known as non ideal or real gases. We take a quick revision of the gas laws. Gas laws. Review. First, Boyle's law. Pressure volume relationship. This law describes the pressure volume relationship of gases at constant temperature. It was given by Robert Boyle in 1662, and the law states that at constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. For a given volume V of a gas at pressure P, Boyle's law may be expressed mathematically. V is inversely proportional to P, means volume is inversely proportional to pressure at constant temperature. So PV is equals to constant at a constant temperature. Let V1 be the volume of a given mass of the gas at pressure P1 and temperature T. Now if the pressure is changed to P2 at the same temperature, let the volume change to V2. Then according to Boyle's law, P1 V1 is equals to P2 V2, or P1 by P2 is equals to V2 by V1. Thus, another statement of Boyle's law is the product of pressure and volume for a given mass of gas at constant temperature is constant. Thus, if the pressure is halved, the volume is doubled of its initial value, and if the pressure is doubled, the volume is halved. Second one is Charles' law, the volume temperature relationship. This law gives the relationship between volume and temperature of a gas at constant pressure for a fixed amount of gas. It was given in 1787 by French chemist Jacques Charles and was further developed by Joseph Gay-Lussac in 1802. Charles' law states that at constant pressure, the volume of a given mass of a gas increases or decreases by 1 upon 273 of its volume at 0 degrees Celsius for each 1 degree rise or fall in temperature. If V0 is the volume of a given mass of a gas at 0 degrees Celsius and V1 the volume of gas at 1 degree Celsius, then according to Charles' law, V1 is equals to V0 plus V0 upon 273. We can say it is equals to V0 whole bracket 1 plus 1 upon 273 bracket close. If Vt the volume of gas at T degrees Celsius, then Charles' law may be expressed mathematically. Vt is equals to V0 plus V0 into T by 273. Absolute scale of temperature. By similar calculations, it can be shown that the decrease of temperature results in the decrease in the volume of the gas. The volume of the gas below 0 degrees Celsius will be less than V0 and ultimately the volume should become 0 at minus 273 degrees Celsius. That is, at T is equals to minus 273 degrees Celsius, volume V is equals to V naught bracket 1 minus 273 by 273 bracket close, which is equals to 0. This is graphically shown in the figure 1.1. Thus, minus 273 degrees Celsius is the lowest possible temperature at which the gas is supposed to occupy zero volume. That is, the gas ceases to exist. This lowest temperature at which the gas ceases to exist is known as absolute zero. A British scientist, Lord Kelvin, suggested a new scale of temperature based upon this choice of zero. This is called absolute scale of temperature or Kelvin temperature scale, indicated by writing the letter K. Thus, minus 273 degrees Celsius is 0 Kelvin or 0 degrees Celsius is 273 Kelvin. The relationship between the Kelvin scale and Celsius scale is Kelvin temperature is equals to Celsius temperature plus 273. T Kelvin is equals to T degree Celsius plus 273, where T is the temperature on Kelvin scale and small t is the temperature on Celsius scale. Celsius scale is converted into Kelvin scale by addition of 273. Alternative statement of Charles' law. Equation 1 can be written as Vt is equals to V naught bracket T plus 273 upon 273 bracket close. Putting 273 plus t small t is equals to capital T in equation 2, we get Vt is equals to V naught T upon 273. Putting 273 is equals to T naught, we get Vt is equals to V naught T upon T naught, or Vt upon V naught is equals to T upon T naught, or Vt upon T is equals to V naught upon T naught, or V by T is equals to constant at constant pressure. So, V is directly proportional to T at constant pressure. Thus, Charles' law may also be stated as at constant pressure, the volume of the given mass of a gas is directly proportional to the absolute temperature. Let V1 be the volume of a certain mass of gas at temperature T1 and pressure P. If the temperature is changed to T2, keeping pressure constant, the volume changes to V2. Then according to Charles' law, V1 by T1 is equals to V2 upon T2 at constant pressure. Avogadro's law. V is directly proportional to N at constant temperature and pressure. This law relates the volume of a gas to the number of molecules at constant temperature and pressure. It was put forward by Amedeo Avogadro in 1811. Avogadro's law states equal volume of all the gases under similar conditions of temperature and pressure contain equal number of molecules irrespective of the nature of gas. It is known that 1 mole of any gas contains Avogadro molecules. Also that 1 mole of all gases at 273 Kelvin and 1 atmospheric pressure occupy a volume of 22.4 liters. This means that as long as the temperature and pressure remains constant, the volume of the gas is directly proportional to the number of molecules. Mathematically, Avogadro's law may be expressed as V is directly proportional to capital N. Further, as the number of molecules capital N of a gas is directly proportional to its number of moles, that is small n, so V is also directly proportional to N at constant temperature and pressure. The fourth one is the Graham's law of diffusion. Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the density of the gas at constant pressure. Mathematically, R is inversely proportional to the square root of density, where R is the rate of diffusion of the gas and D is the density. When two different gases are under consideration, then according to Graham's law, the rates of diffusion of different gases are inversely proportional to the square root of their densities under similar conditions of temperature and pressure. Mathematically, R1 by R2 is equals to square root of d2 by d1. Further, as twice of vapor density is equals to molecular mass. So, R1 by R2 is equals to square root of m2 by m1. If two gases diffuse under different pressures, say P1 and P2, then the rate of diffusion varies directly with pressure. In other words, greater the pressure, greater is the rate of diffusion. Hence, Gram's law can be written as R1 by R2 is equals to P1 by P2 square root of d2 by d1. Or we can say R1 by R2 is equals to P1 by P2 under the root m2 by m1. Dalton's law of partial pressure. This law states the pressure of mixture of non-reacting gases contained in a vessel to their individual pressures. Dalton's law of partial pressures. The law relates the pressure of the mixture of non-reacting gases contained in a vessel to their individual pressures. The law states at constant temperature, the pressure exerted by a mixture of two or more non-reacting gases enclosed in a definite volume is equals to the sum of the individual pressures which each gas would exert if present alone in the same volume at same temperature. The individual pressure of the gas is known as its partial pressure. Mathematically, Dalton's law can be written as P is equals to P1 plus P2 plus P3 and so on at constant temperature and volume, where P is the total pressure of mixtures of non-reacting gases and P1, P2, P3 are the partial pressures of the gases. Ideal gas equation. The combination of Boyle's law, Charles' law, and Avogadro's law leads to an equation which relates the variables pressure, absolute temperature, volume, and number of moles. This equation, so formulated, is called combined gas law or gas equation. According to Boyle's law, V is inversely proportional to P. According to Charles' law, V is directly proportional to T. According to Avogadro's law, V is directly proportional to N at constant temperature and pressure. Combining these three laws, we get V is directly proportional to N and T and inversely proportional to P. So PV is directly proportional to NT. So PV is equals to nRT, where R is the constant of proportionality of gas constant. And this equation PV is equals to nRT is known as ideal gas equation. Here P is the pressure, V is the volume, N is the number of moles, T is the temperature, and R is the constant of proportionality known as gas constant, and it is independent of amount and nature of the gases. Thank you.